Okay, hello everyone. Welcome to ALTIBASE webcast presentation. First of all, is anyone first time to listening to this session? Okay, just in case you don't know me, my name is Daniel Seo. I'm an education consultant in ALTIBASE Corporation. I already had two sessions before. The first one was about architecture, and the second one was about table space management. And today we will have a look at how ALTIBASE HDB guarantees durability. Okay, before I start durability, I want to talk about the transaction first. But I believe the people who are listening to this seminar, I mean, most of them already know what transaction is. The transaction defines a unit of task that comprises one or more SQL commands as a group inside the database. Okay, and because it's one unit of task, the SQL command inside the transaction are executed as either all or nothing. For example, let's think of bank transaction. If you want to do money transfer, then it cannot be done by just single SQL command. You have to check how much you have in account. Okay, you have to check how much you have in your account, and you have to decrease that amount from that account, and you have to increase that amount from the account you're transferring to, and then you have to check whether it has successfully transferred. Okay, if either one of them fails out of these four commands, the entire transaction um, is fail. Okay, so the transaction is where a number of SQL commands are grouped together as a single task, and each single SQL command is called a statement. Okay, and in order to execute the transaction properly, the four condition has to be met, and we call this condition of transaction integrity. Okay, atomicity. This one, it means all or nothing. Okay, the money transfer has to be either succeeded or fail. Not like the money is reduced from one account and there's no increase in other account. So the transaction cannot be partially successful. Okay, it's either the transaction is completely executed or none of them. Okay, the second one, the consistency, is the state where the DB has to maintain all the integrity condition after transaction finish executing. Okay, so the database has to be in a consistent form, one form to another. The isolation is the state when multiple transactions are executing same time for one record. They shouldn't be affected each other. For example, I'm transferring money to my friend's account, and other person is also transferring money to my friend's account at the same time as well. Then that doesn't mean I should be affected by him. Okay, I should be able to send the money regardless of his transaction. Okay, the last one, the durability is where all the contents of the committed transaction have to permanently remain. For example, I finished my money transfer to other account, but it's not actually transferred due to the problem in the bank system. Okay, so that shouldn't happen. So once a transaction has committed, the resultant changes are not lost regardless of circumstances, such as system failure. Okay, the transaction has to meet these four conditions. So ALTIBASE HDB guarantees reliable transactional processing by implementing a database server that satisfies all ACID requirements. Okay, we call it ACID requirements. Okay, what I'm going to talk about today is how ALTIBASE HDB guarantees durability when managing transaction. Okay, the transactions durability. Okay, so like I said, durability of transaction is the property that when a single transaction finishes executing, then the contents have to be available to the user in any kind of situations. Okay, so it's a property that committed transaction has to be guaranteed. Okay, guaranteed against any kind of system failure before modification of database object is flush. Okay, flush into the disk. This is when the DBMS sent a commit response to the user. Okay, more precisely, after transaction has been committed, the committed transaction must be guaranteed. Okay, even if a database failure occurs before the change data are physically written to the disk. Let's say, for example, like I said previously, I had successfully transferred money to my friend's account. Actually, I don't need to know whether the entire process of bank transaction is saved into a database or file, or is it saved in real time, or is it saved on a regular basis. I don't need to know all of that. All I need to know is whether the right amount of money is displayed on the screen, okay, whether it's from the ATM machine or whether it's from internet banking or whatever. Okay. Then where do all these contents are saved into? Okay, first of all, the user transfer money to other account and the amount of balance is changed, and the database saves the record of change amount into the data file, and then later user checks the change amount. Okay, and after all these processes, the final amount money is shown. However, in a lot of databases, the user does not save the modified data into data file in real time because of the performance issue. Okay, you would think when data is modified, then the data inside data file will also be changed straight away, but that's not true. The data is firstly modified from the memory and the disk the second. Okay, this is same for memory DB and disk DB. Okay, then what if the system shut down unexpectedly while modified data was only in memory, not in the disk? Okay, probably the transfer process cannot be guaranteed. Okay, then how can we guarantee full durability of data? This is why a lot of DBs manage physical file called log file. Okay, along with data file. Okay, the transaction log is firstly recorded before the data is modified. For example, in order to decrease the money from bank account A, then its log has to be recorded first, and after the log is recorded, then the actual amount is decreased from the account. Okay, same for account B. If the amount of account B needs to be increased, then its log has to be firstly recorded, and then the actual amount is increased. Okay, then how does log file guarantee the durability of transaction? Okay, like I said, the modification firstly occurs from the memory, not from the data file. But even though the DB shutdowns unexpectedly, the log contains information about change amount, so the database can perform recovery using log file. This is how durability is guaranteed. Okay, however, there's a problem here. The log is first recorded into somewhere, then where? They are recorded into the log file in the disk. In order to guarantee durability, every log has to be recorded into the log file without missing one single of them. Okay, but this occurs disk I/O. Okay, the disk I/O. So the performance is reduced. Okay, therefore you should know there's a trade-off relationship between performance and the durability. Okay, trade-off relationship. Okay, then let's have a look at how database guarantee durability through the diagram. Okay, as you look at the diagram, the disk data file contains data called 10 here. Okay, the 10. And then so does memory. Okay, let's see how they are operated when transaction occurs. Okay, so the client wants to change the value of C1 from 10 to 20. Okay, then what is the first thing to do? Of course, the log of changing 10 to 20 has to be recorded first. Okay, but we should carefully watch where this log is saved into. Okay, the durability is guaranteed when log is saved into log file located on disk, but when log is saved into disk in the unit of statement real time, then there will be a huge amount of disk I/O. So ALTIBASE HDB first records transaction log into some space called log buffer. Okay, the log buffer in the memory, and after that is flushed into the disk. Okay. Okay, log that contains information about changing from 10 to 20 is now saved into the log buffer. Okay, now the actual data has to be changed from 10 to 20. Okay, but where first? Okay, it is firstly changed from memory, not the disk. Okay, so the memory is changed to 20, but it is still 10 in data file. Okay, so what if the DB shutdowns all of a sudden? The user didn't execute commit, so the transaction rolled back, and the DB shows the value of 10 to the user, not 20. Okay, then let's try commit. Okay, now the DB has to show value of 20 no matter what circumstances because the commit has been executed. But how? When user execute commit, the log that also contains information about commit statement is recorded into log buffer. Okay, the commit log is here. Okay. So when they are flushed into the log file in a disk before the user is informed. Okay. The durability is guaranteed as the log is recorded into log file even though it's not recorded into the data file. Okay. Now let's suppose there is abnormal shutdown. Okay. Abnormal shutdown and server restarts. Okay, it will restart from the empty state as the memory is volatile. Okay, they're all empty. Okay, this one empty because memory is volatile. Okay, so when it restarts, the DB unloads the value of 10, not 20. Okay, it almost to 10 as the DB had upload shutdown. However, this violates the durability because the data was uploaded as it is. Therefore, in order to guarantee durability, the value 20 is uploaded. Okay, from the log file. Okay, after checking the commit log, and the log says the value 10 was actually changed to 2. So when DB restarts like this, the durability is guaranteed. But the important part is there are two different methods of flushing log from log buffer to log file in a disk. And ALTIBASE HDB only choose one of it, and they are called asynchronous and synchronous. I'm going to talk about the features of asynchronous and synchronous methods. Okay, so the durability levels can be chosen by configuring the property called commit write wait mode and log buffer type. Okay, the durability level is assigned when DB starts up, but this cannot be changed while DB is operating. Okay, you need to change the property and restart the DB. Okay, what do these two properties means? Okay, firstly, for the flushing method, the method of asynchronous synchronous, the commit write wait mode. Okay, this one. I want you to listen carefully, and at the same time, I want you to think of the diagram that I just explained. From the diagram that I just explained, do you guys remember when commit is executed, it is firstly recorded into log buffer and then flushed into the log file. So this property actually decides whether the transaction will wait until all the logs are flushed into the physical log file. Okay, after it's been committed from log buffer in a memory. So when it flushes by asynchronous way, then the transaction finishes executing only after the log is recorded into log buffer. But when it flushes by synchronous way, the second one, the transaction does not finish executing until it is fully recorded into the physical log file. Okay, the asynchronous method is fast because the transaction finishes executing once it is recorded into log buffer. But there's a little durability issue when DB shutdowns abnormally because the transaction finishes only after it is recorded into log buffer, not until recorded into the disk. Okay, the synchronous method is slower than asynchronous because the transaction does not finish executing until all the contents are recorded into log buffer and copied into physical log file as well. Okay, but because the transaction finished executing until they are recorded into physical log file, the full 100% durability is guaranteed even though the system shut down abnormally. Okay, the log buffer type is the property that decides which types of log buffer the ALTIBASE HDB will use. Okay. The log buffer is managed from the memory, not from the disk. That's why it is volatile. So there's a different level of safety depending on the location of log buffer. So when log buffer type is 0, it means the log buffer is used from the OS kernel. Okay, and when log buffer type is 1, then the memory area from ALTIBASE internal process is used. So whether the log buffer can still be used or not when there's abnormal shutdown is depending on which log buffer type is used. Okay. So when the log buffer type log buffer from ALTIBASE process is used, this log buffer becomes volatile when DB shutdowns abnormally. But when log buffer from OS kernel is used, the log buffers can still be used. Okay. Even though the DB shutdowns abnormally, because it's database problem, not the OS. Okay, then let's have a look at how durability is guaranteed by configuring these properties in ALTIBASE. Okay, so there are two types of configuration in ALTIBASE, the performance-based and the safety-based. The performance-based configuration focuses on the performance of the transaction handling. Therefore, we need to set the commit write wait mode property to 0. Okay, the asynchronous way. So the performance-based, the transaction finishes executing once it is recorded in log buffer. Okay, but to improve the safetiness, it used the log buffer of OS kernel and not the ALTIBASE process. This is because the OS has lower probability of getting system failure rather than DB. So this method not only handles transaction fast but also guarantees safety. Okay, the diagram is an example of how durability is guaranteed, which is quite similar situation that I've shown previously. The client wants to change the value of C1 from 10 to 20. Okay, then the log is firstly recorded into the log buffer. Then the value 10 is changed to 20 from the memory. And now what do you think the client will do when commit is executed? Okay, because it is performance based, the commit log is recorded into a log buffer. Okay, then the transaction finished executing and the OS is now in charge of flushing into the log file. Okay. Okay, so even though the DB had a normal shutdown while it was not flushed into the log file, the value 20 can still be guaranteed because it was actually flushed by OS and as the log buffer was in the OS area. Okay, so this performance-based configuration can guarantee durability and the fast performance of transaction speed except when there's an OS crash. Okay, the safety-based configuration focuses on the durability rather than the performance. Okay, so we need to configure the property commit write mode to 1. Okay, the synchronous way. And because it is safety-based, it guarantees 100% durability against any kinds of system failures such as DB failures, OS crash, and so on. Okay, so when you look at the example, how that process is similar. In order to change the data, it has to firstly record it into the log buffer, okay, and then change the data. The difference is from after the commit is executed. Okay, you notice that the transaction does not finish executing even though the commit log is recorded into the log buffer. Then when does the transaction finish its executing? It finishes its executing after the log is flushed into the log file. Okay. Commit success is returned. Okay, this is why the performance is reduced as it waits until the log is fully flushed into the disk. Okay. However, you should know the main feature of this configuration is that it guarantees durability of data against any kinds of situation. Okay, so it was pretty much about today's web seminar called How is Durability of Transaction Guaranteed in ALTIBASE HDB. Okay, I hope you guys enjoyed this session pretty well. Okay, think I'll stop here for today, and I'll see you guys in the next web seminar called What is MVCC. Okay, I'll see you guys next time.